Hello everyone, welcome. So, in the last session, we finished modeling of all primary block assembly related parts. In this session, we will quickly arrange them and make an assembly and take the assembly drawings. Okay, I will show you assembly drawing of this, where this is a half sectional front view, and you can see the individual parts being called, represented by these balloon callouts. Mm, we have already created, and using this you just see there is a body and a cap are these bottom bearing and top bearing are compressed by cap and body, and these are bolted here and locked with nut arrangement. This is a simple arrangement. Quickly I will go to the assembly session. Open the assembly session here, and you will be entering into the assembly mode. And in this is part library. If it is not showing, go to desktop and open your uh, folder you have kept in. So all the parts and previews are visible here, and see this assembly pathfinder also. You have to parallelly see these two things for assembly creation. So as a first instance, call this select this body 001 and drop it, drag it and drop it onto the screen. The body has come over here. Next, look at the next part. But second part is cap. But before adding second cap, what I feel is you inside this bearing bottom half and bearing top half will sit inside. So leave it. Once you arrange, assemble these 3 and 4, that is bearing bottom half and bearing top half, then over and above you can assemble this cap over here. It need not be sequential. Based on the requirement, you have to arrange yourself. Here I will choose bearing bottom half. Uh, so this cylindrical surface, you just mate it with this curvilinear surface of this body, and this stud will go inside this hole. Select the cylindrical face of the stud, and then select this cylindrical hole kept inside this body perfectly. Now it is sit inside the uh, body. So once it is assembled, take immediately the bearing top half and select this cylindrical surface. I will zoom it, and align with this cylindrical surface, and then select this surface and select this surface, and then now select this surface and select this surface. Now you see the bearing bottom and bearing top, they have perfectly aligned. Okay, now bring this cap. uh, these planes will come in between. I will just for a moment I will hide these planes. Now I will go to part library again, choose this. Now you bring your second part, that is cap, which is at the top. um, just you what you do is match this inner cylindrical surface with this, and then align this center of this cylinder hole with this hole over here. You just check with the front view. As you see in the assembly, there is a gap provided here. Now it is perfectly arranged. The top cap is perfectly arranged. Now nothing much is left. You bring the bolts and nuts and lock it. That's it. The fifth one is the bolt itself. Bring it. Now select the cylindrical surface and select the inside hole here inside the body, and now mate this inner surface to the slot, inner face of the slot, and then align this side surface with this. Now perfectly it is assembled inside the body. Now there is one more instance, one more bolt, similar bolt I have to call here. So instead of that, again calling it, I will create a pattern of this. We will see how I will do it. Go to Assembly Pathfinder. You select this part from the specification tree, or else you can select it from the screen area. Both options are there, and select here one option is there, pattern parts. So select it. Now select any parent part. Okay, select this parent part and select the holes, and after that you select the parent hole and just right click on it. Your one more instance will be created. No need to call it again, assemble it. You will save much time here. In complex assemblies there will be a n number of boards like this. Then the designers use these patterns to create there itself. They will call one part and they will make array of it or pattern it. Okay, I hope you have understood it. Similar way we will call these nuts and bolts. Here again you go to this assembly drawing. Here you see the seventh part is called at the bottom, and the sixth part, that is nut. Both nuts are seventh one you have to call first, and then you have to call sixth one. Okay, so seventh part, that is nut, lock nut, I will call here. I will just rotate. I will pick the bottom surface and mate it with this flat surface of the cap, and then I will align it with this cylindrical surface. Okay, now same nut is going to come here. So I will go to Pathfinder, and it will be easy for me to pick the part here. So I am picking it from here. You can pick it from screen area itself, there is no issue. And select this part, click on pattern parts command, and select this again, this body, and select the holes and select the parent hole, and right click the on other side. This nut has come here. Okay, the next thing is next part is sixth one, that is nut with different width he has given. Select the bottom surface, select the top surface of this bolt, and then select the inner cylinder and this bolt cylinder surface. Now escape from this. We can just change this color. Okay, and now make a pattern of it. You can make it as we did for previous parts. Okay, now within a very quick time, then last one I have to insert this shaft inside this hole and just take this. Now the assembly is over. You can check it in top view and front view and side view how it looks and mm, isometric view. Just save it as as.asm file in the folder itself. I will save it as plumber block assembly. Save it. Then next step is to create the assembly drawing. Uh, Go to file. Here create drawing option is there. Click on it. Say OK. And now say next. You can custom here whatever the view which is being asked in the examination. In that way you have to put this and take this freeze that position and take generate that view particular view. Here you change your sheet from any size to A4 sheet. Remove this background. Bring this view here and try to accommodate this view in this layout 1:1. If two views have been asked in the examination, you just use this principal view and click on this view. If you bring back in the bottom side, top view will be generated because it is a first angle projection. Front view will be always on vertical plane, top view will be on horizontal plane. When you rotate the HP by 90 degree, as you have learnt in different type of projections, similarly first angle projection, top view will be at the bottom. Okay, now if you want to uh, call the now sometimes you will ask the half sectional front view. So how to do it? Go here, one option is there in section view. Under this broken out section view, click on this, select the view you want to get the section and draw a profile at the center, and I am defining the area to be cut. That is the idea. Now finish it. Now depth, it will ask the depth. Now assume that I am in front of this assembly. How much I should go inside, that is the idea. Okay. So I am 25 because bearing length is maximum 50. So I will put 25 and enter. It takes time, I think. Uh, I used a different method. I think I will just create the views again. Okay, I've used broken out section here again. I will use the profile. Okay, now press finish and you have to, I typed here step, so in depth I have to give 25. Now you can see the sectional front view of this assembly. Now call the balloon callouts and the material schedule you can add in with this part list, pressing the part list icon. You select the assembly you want to call the balloon callouts. Randomly it will come. You later on you can change your setups. You can reduce the column size here, width, everything by reducing it a little bit. I will change this so you can accommodate, and even you can use the fonts you want, like your MS Word. And using the smart select icon, select all the balloon columns at once and make them as a break line, and also change the color you want, text, everything. If you go to the attributes, you can have various options. Just bring them back into the sheet layout, arrange it. Okay, that's it. And now you can save your assembly drawing as a .dft. File should be same. There is no problem because this is a different file. Save it in this folder you have created onto the desktop, and now you see this here in your folder all the models, and this is assembly.asm file, and this is .dft file. This should be there on your desktop once you finish your all process. Okay, so I hope this gives you a clear idea on creation of models, uh, assemblies and assembly drawings for this particular assembly. Um, Frequently, if you look at the question paper, one of these assemblies, along with this, one more assembly is there, simple assembly, that is machine wise. I'm going to take it up in the next session. These three, out of these three assemblies will be frequently asked. So practice these things more, keeping the time, record the time and practice it, because you will not get much time. Many of the students, what I observed is, they will finish the modeling, they will leave the assembly, and they will assemble randomly. So what they lack is, they know but they are and they have not practiced it fast, because once you become familiar with the commands, you have to use it uh, uh, with a greater speed. Speed will increase when you practice it more and more. And using the drawing parallelly, you have to use the drawings and use minimum operations to create these models. Okay. We will meet in the next session. We will take up the next assembly. Mm, Meanwhile, you practice the assemblies what I have covered in this video sessions. Okay. See you in the next session.